preview stream, live, stop streaming. Okay, so hello everyone. I guess this is supposed to be a start of my streaming of my very first kind of public streaming session, and it says it doesn't receive data, but I guess this just simply means the quality may be not the best. We'll see. Okay, basically what I'm going to do, I want to show you some sort of just a little exercise in Python programming. So I'm using this for program which is very good for editing different files, and so basically manipulating your text files. And then I also have the Sigvin terminal, which I can use for running. Well, actually, for this simple tutorial, I don't even need Sigvin. So all I need is this file, and then I have Python installed in my computer. So, well, that's what I'm basically going to do. Now the task is the following. So, well, let me just start with this test .py. That will be basically my file where I'm going to implement the following problem. Okay, so what we need? We need a let's say we have a sequence of some numbers. These numbers could be anything, integer or floats or whatever. Now, we also want to make an arbitrary permutation of this sequence and then return it to the user together with a way of reproducing or reconstructing the original array of data elements. Okay, so now no, I don't. Now I also want this arbitrary permutation to be different every time I kind of get it, right? But I also don't want to send the original array every time I generate um, the arbitrary permutation. So that means instead of sending the original array of elements, I will be sending some much lighter object, let's say integer or something else of similar size, by which I will be able to restore the original sequence. Now, okay, so let's do a little bit of practice. So first of all, we want to make a function that will generate this sort of initial array, right? The def init 1 2 1 2. That's my kind of convention, and then I first initialize my array to be an empty array, and then I want to do this thing. So let's just do this little test. Print math random import mass, and then just a random. Yeah, I'm not a perfect human, so of course, and that's the point. You don't need to remember everything. So okay, you just need to remember where to get what you need. Okay, so that means import random. Random is a module which we will be using, and then there should be some sort of seed get state. Well, they have some sort of around return a random integer n such that n is less than. Okay, that's interesting. Let's maybe do that. Rand int from a to b. And then we'll be doing rand int from 0 to 100. Okay, and then let's try to run it again. Okay, it gives 66. Again, 93. Yeah, perfect, good. So now we want to, so for an array of 10 elements for I in x range of 10, we'll do this. Well, we'll just generate this number 1 2 1 2 yes, and then append this number to this array. So, well, of course, what that means is this: for I in x range, that means I changes from 0 to 9, including, well, this I, of course, is never explicitly used here, but then it's basically means you repeat this instruction 10 times. You repeat whatever is nested in this for loop. That may do. Here you can also print this res, and so you can see, well, let's see, basically the difference is that if you print this res and after all 10 iteration, you will basically see the final result. Okay, and then this is what happens. This is your final result. Call it again. Here's another sequence of integer numbers. Now, just to kind of illustrate the idea of this append, you can print this res function, or maybe after res array after every iteration. So let's do this. Python test. Now this is what you see. This is what you get. Initially, in the first iteration of the loop, you get only one element added, and that's why you get this 93. Then in the next next iteration of the loop, you add another element, another, and so on until you get all 10 elements added. Well, if you run it again, you get a similar idea, but a different sequence of numbers. So that kind of looks interesting. Okay, and well, of course, in typical calculations, you don't need to, show so many printing results 1 2 1 2, but you want to return the results. Return res, right? So this is your initialization function, and then you can do it this way. So init, but of course, remember that res here is not the same as res here. It's random an array of random integers. The length of the array is 10. Now here we'll create another function which will be, we will call it randomize. Well, I mean, at this point he initially just take an input and it will generate an output. So I guess what we want to do is first to make a copy of the input. Now, okay, return out. Okay, that's, I mean, so far it doesn't do much. So we do original, and then we can do print res, and then we can do permutation, which will be randomize of res, and then we can print permutation. Let's see how it works. Well, I mean, that's what you would expect. The two arrays are the same. Now let's do actual permutations here. So how can that be done? We will basically need to do step 1, generate permutations, and by that we will basically understand the indices of the elements of the original array which we want to exchange. Okay, so that will be, so let's first do sz size of out, len of out. So that's how many elements in the out we have. That's actually 10, right? And that means so our indices we will be generating right now should not be bigger than 10, or actually 9, not more than 9. And that means we will just do the same thing. We will do a similar idea from here, but we will create two arrays, m1 and then m2. Now, and then here x range will go to size. That means no, not to size. Could be actual, let's say 3. We want 3 permutations, some permutations of the original, but indices of these permutations will should be not larger than sz, and we do this for m1 and so for so out, how do we swap two numbers? TMP will be out of m1i, whoops, is TMP. That's basically a standard way of swapping the numbers, and so that is the way we generate a new permutation. Let's see how that works. Whoops, that doesn't work, of course. And why? Because run it again. So okay, that's what happens. So you see, this is your original sequence, and this is the one which is obtained by these 3 permutations, 3 pairs of permutations. Now we just need to define a way to reconstruct. Okay, let's define a new function, restore, and that restore will take out and m1 and m2 two keys. It should basically do the same operation as here, but in exactly reverted order. So that's, and also we'll do this randomize. Okay, maybe we'll call it out, and then we already have this you know, keys thing, so that will be actually simpler. Now we just need to do, okay, we still need the size of these key sequences, and we do this from so how should we do that? Well, I guess the simplest way would be to do this way. So I goes from 0 to sz1 minus 1, so we can introduce an inverse counter, which will be sz1 minus 1 minus I. So as I goes up, j goes down, and we basically swap in the inverse order. Okay, so and then we basically 1 2 1 2 return out. That should be our inverted thing. So okay, let's do it. It is like original will be inverted randomize of your permutation of with key 1, key 2, and then you just print original, which is supposed to be this one as this. Okay, let's check it now. Well, okay, so what happens? This is different, but this is the same. This is everything same. Okay, well, that permutation doesn't seem to be very well. Actually, no. So this is different from these two. This is also different. This different. This different. This is, well, there are many differences in this permuted, but the restored and the original arrays are the same, so that means our procedure works. Well, now what we can do, we can play a little bit with kind of do generalize these things. So length of array is was 10. Now let's make it any random number n. So n, and then you will have that is the size of your array, and this is well, let's say your, okay, maybe we can do this a and b. So a and b, these are kind of integers, the range of integers, size of the array, size of permutations. Well, actually, it doesn't make, probably at some point it doesn't make sense to make n very large, because, well, after many permutations, some of them will be actually redundant, so you may accidentally kind of swap elements back. So it's just randomization of 3 pairs would be similar to randomization of like 100. Well, maybe you can call it A, B together, so from 0 to, let's say, 1000, and then you want to have 10,000 of elements, and then that will be your permutation size. There's no simple way just to understand what is going on here. But the guess is that, well, this kind of thing should work pretty well. Okay, so I hope my streaming session is still live. Well, and actually interesting, so it didn't take much time, only about 20 minutes. So, and just in 20 minutes we have kind of made this sort of program. Now what can you do with that? Well, I guess you can in principle think about some sort of spin system, or some more likely encoding or compression problem. So if you, I mean, let's say you want to modify this large sequence of 10,000 numbers, you don't want like kind of to send all of them together with the original. You can just modify by 1,000 or maybe just 100 permutations. Well, that actually doesn't matter. This is what matters. Well, just 100 permutations, and so you only need two arrays of 100 to define a new permutation and also to restore the original array of elements. Okay, I guess at this point this is what I wanted to talk about today, and I hope you like this video, and I guess I'll go get some tea for myself. Now, okay, let me stop the streaming.